Hello. Today, the title of the talk is Tree Sitting Will Continue Until Scala Highlighting Improves. It's a reference to a phrase, you may have heard of it, about the beatings. But in the last ditch attempt to introduce more people to the subject, I added another slide to it, and now I have to adjust the title of the talk, because now it's with AI. So now the talk is all AI, and you're going to enjoy it. Like this will be on the front page of Hacker News, I promise you. So who am I to talk about this? Well, Anton, I work with Scala since 2014. Jakob, there's another way to go around, not in front of projector. I advocated for Scala everywhere for years. Services, front-end, CLIs. Like, if you use Scala, you can do so much more with it than just back-end services. I maintain and contribute to some of the parts of the Scala JS and native ecosystem, and I run a Scala-centric blog. You may have seen this gorgeous design. This is the extent of the CSS. There's not more to it. This is not a big room, so that's good, so that you'll be able to see most of the code. But if you don't, I put two QR codes, one for the code, one for the slides. But you know, it should be fine regardless. So why am I doing this talk? I want to motivate you because there's only 4 big issues that our industry should really be focusing on, like should be concerned with. It's security, scalability, maintainability, Scala, and making sure the code snippets are pretty. So that's the 4 things on which, those are the pillars on which our industry is kind of stationed. And you know, just with like any visionary, you might laugh at this, but soon in time you will see that I'm right. But in seriousness, we consume a tremendous amount of code, snippets through social media, blog posts, YouTube videos, and slides. And just like with general typography, if you read a poorly formatted text, you will basically drift off. You cannot read that. So it is important. And we notice the difference between the things that are nice and are subconsciously or otherwise. And furthermore, this didn't really start as a talk. At first, I just wanted to do an in-app, in-browser web application with Scala JS. And I didn't want to do it because to do this, it sounded like I need to learn way more about JavaScript and WebAssembly than I ever wanted to. But Timebox experiment, it went really well, so I decided to explore other platforms on which Scala is available. And surprisingly, I went native first and then JVM. So it's a journey, I'll take you on it, but I think it's interesting. What's in it for you, the Scala developer? Most of you are Scala developers, or you work in companies that use Scala. You'll learn a bit about Tree Sitter, because it keeps popping up in the tooling space in general, and you will see Scala on all 3 platforms, with a focus on JS and native. And you will learn a useful pattern, I think that's useful, for building interfaces in Scala 3 that work across platforms. And you will nourish or uncover this obsession with syntax highlighting you didn't know you have. Because if by the end of this talk you look at a snippet and it's highlighted poorly, and you feel that deep burning sensation inside of you that life is just not as good anymore, I've done my job right, because now you will also be obsessed. You will not be able to focus. So syntax highlighting, we all know what it is, but we often don't talk about why it's useful. We're basically, with syntax highlighting, we're trying to showcase the structure of the program through the usage of colors, text decorators, and it's usually performed without type checking or involving the compiler. It speeds up the comprehension of the code by involving the subconsciousness, because both highlighting and indentation are used for that purpose, and additional tools are not required to just read highlighted code. Hey. It's often used without the compiler because speed reason, and also most of the time highlighted snippets are not really valid code. So it's a very different set of problems than just compiling things. So colors help navigate through the code without having to read the letters. If you see a keyword and it's highlighted in a consistent way throughout the program, your brain does not read val, var, if, then. It doesn't. It just sort of skips right over that. And indentation does the same, but for blocks and structure of the code and nesting. So in a particularly egregious case, so unfortunately, syntax highlighting on a white screen is a difficult problem. We don't have enough colors available. So I'm going to, just for now, switch to dark mode. But, well, that's even worse. But on the top, it's not highlighted. So it's all the same color, all white. On the bottom, you can see that the keywords if and then are highlighted. Position token is highlighted. The operators have a different color. This is the stuff that your brain skips, because you know what it is. And the purpose of any readable code is just to skip as much stuff as possible and just focus on what the intention is. That's where highlighting and indentation really help. The most popular approach to this is highlighting with regular expressions. It's most common. Most commonly using highlight.js, this is sort of, it's in every single blog, every single static site generator, every single website. There's things like Prism, but I don't think it's very maintained. Regular expressions are used to just identify known blocks of code and then highlight them like this. And if you've ever written a regular expression parsing something very difficult, or multi-line, for example, you know it's fast, it's easy to write. The code in the browser is tiny because regexes are built into the browser, into JavaScript runtime. But it struggles with ambiguity. It has limited context understanding of the code. And soft keywords, Scala loves soft keywords. Like every single update, def, update. How do you do in a regex? Like how do you make one update highlighted differently? You have to have those special cases for a lot of things. And obviously with special casing everything, it just becomes unmanageable very quickly. So I think in 2019, Max Brunsfield started working on an alternative solution. So TreeSitter was born, I think, in the depths of GitHub, because GitHub shows a lot of code. So that's where this particular system comes from. Unlike regexes, it's a comprehensive parsing system, so there's a lot in it. You can author grammars in JavaScript. You have a query language for syntax tree extraction, manipulation, tagging. And it also comes, which is a rare thing, but it comes with a comprehensive set of CLI tools, templates, workflows, like everything for you to start building grammars. And the testing infrastructure, which is way more important than people realize. And lots of languages already have high-fidelity grammars. Like some of the grammars are maintained by the companies that author those languages or work in those languages. It's used on GitHub for syntax highlighting. There's a lot of companies that do security analysis and static analysis of code through the usage of TreeSitter. Of course, it has limitations. It's supported in some popular editors, or it's either built in or it's built on top of TreeSitter. For example, NeoVim Z, oh, there's a mistake here. Sorry, I meant popular editors. So NeoVim Z and Helix. And with Emacs 29, I think you can enable a mode in which it basically works with TreeSitter, but you know, who cares about Emacs, right? So let's see what TreeSitter is. So the grammars, you define them using a JavaScript DSL. This one is taken directly from the TreeSitter Scala grammar. There's at least one maintainer in the room of that grammar. And this is the enum definition in Scala 3. And the sec, repeat, and optional, they all come from TreeSitter. So they're sort of helpful things. And in this case, you can sort of read it. Like, what is an enum definition? First, you might have annotations, so some numbers, so repeat annotation. Then you have the enum as just the word, the keyword. Then class constructor, so because it's a reference to another node, because it could be very complex, multiple parameter lists and all of that, so we need to parse that. Then you have a optional extends clause, optional derives clause, and at the end, you have the body. So you define your grammars like this. TreeSitter provides a very small number of things, but it's enough to express complicated things. And for the rest, you can write C, which, you know, Haskell does, Scala does, Python does, specifically to deal with indentation. It's a hard problem to solve. And so for that, you need some special C code. I think maybe the most useful feature of TreeSitter is that it also comes with the support of the query language. So it's a scheme-like, Lisp-like language that allows you to deeply match on the nodes. So in this particular example, we have a call expression, which is just like calling a function with parentheses. And what we're saying is, take the function name out of that node, which is a node of type operator identifier, because Scala has restrictions on what the operator identifier can be. It cannot contain certain characters, and tag it with the name function call. So we're tagging it with a particular name, and the names are sort of meaningless. TreeSitter does not really impose anything. A lot of the systems, they basically inherit stuff that NeoVim came up with. So NeoVim uses function call, and then it highlights that in the editor with a particular color according to the theme. So, but the actual names, they are meaningless. TreeSitter doesn't care what you call them. So it's much more powerful than this example. You can set like attributes, but it has limitations. You cannot match on arbitrarily deep nested nodes, which causes some issues for people trying to do more than syntax highlighting and sort of just parsing. Because if you're doing it for security analysis, depending on how the grammar is structured, this query might not be enough. You might have to write custom code. And that's exactly what we're going to do. So once you have that grammar and those queries, you can generate a gigantic, like 5 megabytes of code, C file, and which references this TreeSitter runtime to parse the text into some sort of syntactic structure, which you can then use. Generated C parser can be compiled to WASM, which is an important thing for this talk. It's usable on the web. And there are some first-class bindings for popular languages, like Java has one directly under the treesitter organization. I think Swift has another one, so that you can use it easier. But it all boils down to just that C code that treesitter is written in. Not going to cover all of it. This is the introductory video. Actually, Chris Kipp, the author of NVim Metals, if anyone here uses NVim Metals, he put me onto treesitter and ruined my life by talking about syntax highlighting, which is why I'm talking to you now. It's been 4 years. But watch this video. It's fantastic, because treesitter can do incremental parsing and all that. So the project I'm trying to present here currently consists of a Scala JS front-end application, a Scala Native CLI, and a Scala JVM backend, which I had to make a decision this morning that I'm not going to build the rest of it. And I'll tell you why. This is all very new. So this is sort of the outline of how the application looks right now. I use it for my purposes when I post things on Twitter, but code on the left using basic code mirror, we just bind to it. Code on the right is highlighted with treesitter, and hidden just out of sight is a comparison page with highlight.js, so you can immediately see the difference in quality. I'll show it to you in a second. The project itself, Scala JS frontend, we use Vite. If you ever done any Scala JS with full stack applications, Vite, we just use that as a build tool. Treesitter has special bindings called web treesitter because it's intended to be used on the web as well. They're designed to work with parsers compiled to WebAssembly. And there's Scala JS and Lamina just for the basic interactivity stuff. So assume that we took our treesitter grammar for Scala and we compiled that to WASM. Then the process of loading it in the browser is quite short. So you load the treesitter runtime itself. It has to be available. You load the treesitter Scala parser itself. They are compiled separately. After that, you directly copy-paste this from the web treesitter documentation page. And this locate file, I don't know what that does. But you somehow make it all work. Then you construct the treesitter parser, and you load the language so that it initializes it. And what we're doing here, notice that this is JavaScript. I could not actually produce that in Scala.js because I still don't understand JavaScript imports, awaits, asyncs. I don't understand any of that. So I just wrote that little shim in JavaScript and loaded it alongside the app. What we're doing is, once we constructed the parser, we just export it so that it's available in the global scope. And if we look at the bindings to web treesitter, we read the TypeScript file that they provide, and we sort of see that there are the parser, it has a method called parse. That's understandable. It refers to something called a tree. It also has language and query. And this is me just by hand writing some Scala.js bindings. But I can sort of, you can sort of guess that this will not work on native or JVM, because this is very JavaScript specific, and we cannot make this portable, because the goal of this entire project is that the highlighting logic, anything that traverses and navigates and works with treesitter stuff, I want it to be platform agnostic. I don't want to write 3 different versions of the highlighter working with 3 different bindings. So it has to be syntactically identical across platforms. But platforms are very different. So on JS, this is how a treesitter match is implemented. So it has a name and captures. It returns just a JavaScript array because it's a garbage collected language. You don't have to worry about memory. On native, it's actually a struct. And there's a bunch of static methods that you have to invoke in a particular order. There is no extension method. There's no fields. There's no arrays. You just get pointers back. And on JVM, it's yet another query match structure, but it's now a record class, which has this pattern index. I don't remember what that is, but it's in a different place on native. So they don't share anything. There's different memory semantics. You have to invoke those things differently. So, but if we squint and look on the treesitter, what is the core model of it? It has trees. Those trees, they have root nodes. That's the starting point of our entire thing. It has a method called parse that returns tree from a text string. Captures, they have names that you can extract by giving them a query. And they can return a node which it captured. And with a match itself, like when you have a match, you can return an iterable of captures. This is the core foundational model of treesitter. And we're using abstract types in here just to represent that. Using abstract extension methods just makes the whole process much easier. We could have just used regular methods that take multiple parameters, but abstract extension methods are a thing in Scala, and it's a very useful thing. So here's me going through all of this. And does this look familiar to anyone, like this particular code? Have you ever seen it anywhere? Yeah, baby. There we go, quotes.scala. So if anyone has ever done any Scala 3 metaprogramming, you have inevitably found yourself looking at the source for quotes.scala, 5.5 thousands of lines of code, which is implemented using similar pattern, because this is how the API that is available to you through macros and metaprogramming is abstracting away the actual runtime representation of the compiler data structures. Because imagine if they were just publishing direct compiler internals for use in macros. You cannot change them. You have to guarantee stability. That's a sort of a very similar pattern, taken to the extreme, I think, in the quotes.scala. So we will use a very similar approach. So for example, in the JavaScript world, we will take parser.type because it's just a value. That's the actual tree setter, web tree setter parser thing. And then we override capture to be the capture type from the parser. And then we just implement those extension methods by referring to the JavaScript implementation. So we have abstract on the left, concrete implementation on the right. And this tends to work because now the highlight tokenizer can just take that TS pattern, which sort of inherits tree setter interface, and then we can use that to go through our code and implement the logic just in terms of those extension methods. That logic is shared across all three platforms without any changes, and that's sort of part of the goal. Once I had that working and in the web app, I sort of started spiraling, and I was like, oh, what can I do? What can I do else? And we can implement pretty much anything at this point. And so I thought, I want to generate PNG images. There's that website called carbon.sh I really like, which allows you to, you put a snippet in there, it will give you a PNG of like high resolution PNG for your social media posts. And so I wanted the same, but locally and with tree setter, because like the highlighting on there is using highlight.js and it's not very good. So on Scala Native, things are just a bit more tricky because we're now talking directly to the way tree setter is implemented. Like there is no lower level on tree setter. This is how it is. We're just talking through bindings. Our tree setter interface takes the parser and the language because on the lower level, they are sort of separate things in tree setter. Then our capture is just going to be appointed to an opaque struct. Opaque struct means tree setter interprets that internally however they wish. What the user sees is just a pointer to nothing. There is no values in there, no functions on that struct, no fields, nothing. So that's exactly what we do. And then this is just to return one single string in tree setter because you don't have GC anymore. So we have to allocate things, we have to pass them to the actual function, TS query capture name for ID. Then we have to allocate more, then we have to copy that string because tree setter will not manage the string for us. There is no garbage collection. Memory is not managed. You are supposed to do that. And it sort of made me miss GC at that point. And then I had to do that 7 more times in different methods, and then I was sold on garbage collection for the rest of my life. But once you have that interface implemented, from Scala Native, the usage is very simple. You just use the bindings to tree setter. You say TS parser new. You basically say that at some point, when I produce this binary, inside that binary, there is going to be something that provides a function called tree setter Scala. That actually comes from the parser generated for the Scala grammar. So that will expose that one function. And extern in Scala Native says exactly that, that something else will provide it. Then we use that and construct our tree setter implementation. And the highlighting logic works exactly the same way because it's implemented in terms of that incredibly abstract tree setter interface. So the low-level interface to tree setter is a bit hard to work with. So I have a project called SNBindGen, which generates headers, generate bindings in Scala 3 from header files. So that makes it much, much easier to work with. And they're idiomatic and type safe and low overhead. Not zero overhead, as I discovered recently to my dismay, but low overhead bindings. So at that point, what I had was that I have the Scala Native implementation for tree setter. I can parse, I can print out some tokens, and now I need to actually generate the images. I haven't done that since university years, I think. I don't even know how complicated that is. So, you know, working and rendering text and producing PNGs is hard, but believe it or not, using C is a bit less hard than, you know, working with PNGs in UTF-8. So we're going to use Cairo. If anyone has ever heard of that, Cairo, no? Cairo is a very old library. Like, the age of people that know about it is showing. So Cairo actually explicitly says, don't use me for high-fidelity text rendering. So we're using it for high-fidelity text rendering, and because whilst they say don't use it, and they say, oh, use Pango. Pango is yet another library. It originated from the GNOME universe with lots of libraries, but Pango can give you a very accurate sort of measurement and sizing of UTF characters given particular font. And so that makes layouts much easier. I could not get Pango to work at all. Like, it was so difficult. But Cairo has this nice function called Cairo text extents. I'm not going to show you the full code because it's a bit involved. There's a lot of stuff going on. But this is the outline of how you render a text snippet as a PNG. Highlighter, like Cairo provides this function. We get those pixel dimensions, then we manually lay out the lines and the tokens. You will see that it requires a bit more finesse than I thought. That's why Pango needs to be used. So, read the documentation, apparently. Highlighter produces a set of tokens with colors. We convert those colors to whatever Cairo can understand. And we size and place each token individually on the Cairo surface. That was fun. Not really. I had a very ugly mutable implementation similar to what I found somewhere on the internet. That did not work. So I decided to write a 4-liner using a fold left, and it worked on the first attempt. I was so impressed that I told that story about 50 times about this particular project, and now you know. I was so incredibly impressed. I was like, yes, functional. And then once we place all of that characters, we use the extents of the final sort of snippet to move that to another surface, because Cairo cannot resize the surface back. It's sort of immutable. So I allocate like a 4K gigantic image and then place the tokens there, and then I resize it to the actual size. It's all in this file in the accompanying repository called image generator. It's a fun read. I then went a bit further because I said, there are so many C libraries out there. It's just like I'm like a Charlie at the Chocolate Factory. I've never read or watched, but I think Charlie is the kid, right? Who gets all the chocolate. So I was like that. I was the kid with the chocolates. I was like, there's so many C libraries. Like, for example, there's a library called CMark that is the canonical reference implementation of the common markdown format. There is another one, CMark.js in JavaScript. So I used CMark, and I generated bindings to it, and I wrote something that pre-processed some of the markdown files that I had and replaced the snippets directly with HTML with correct highlighting. I'm going to use that in my blog later because I'm still using highlight.js, and I really want to try this. But it works. And now the AI bit, I wrote an MCP server inside of the CLI that generates images of snippets. So I used this in Claude Desktop during some pretend conversation. It wasn't useful. I'm not going to pretend that any of this was useful. I don't know how to use this. I have a horrible idea on how to use it. You will see it on Twitter soon. But I don't have good ideas on how to use this. It's an MCP server that just generates images of snippets that Claude itself generated from some of my other stuff. So this is why there's AI in the topic title. I'm going to update the Scala Days website. So that's done. There's no more AI to go. So native was difficult. JavaScript was a bit easy. JVM was probably the easiest because TreeSitter comes with a Java TreeSitter bindings directly. They only work on JDK 22 because they're using the new foreign linker. And the thing is, the reason they're doing that is because the JVM is actually the JVM bindings are a wrapper on top of the C implementation of TreeSitter. So you still have all the problems of managing the TreeSitter dependency and loading the library and bindings, but you now have JVM stuff on top of it. And you don't need to do any conversions or anything like that. Scala natively understands the JVM bytecode. And so in this case, we just do some name scoping. And I had to do this. Caption name and caption note are separate functions because they conflict, because the record for query match has the same exact extension methods, and I think the Scala compiler gets confused, and it's trying to invoke the Scala version recursively rather than go to the Java version because they have exactly the same name. I don't think it's getting confused. I don't know how it resolve that, to be honest, but that's what you have to do. And at this point, I was writing a JVM service, but thankfully, recently Cat's Effect got released for Scala Native 0.5, so soon I won't have to do that. Because my service is fully HTTP4S type level stack. Because I wanted to have a service just persists some images, puts them on S3, does all of that. I think soon I'll be able to just deploy that using Scala Native without having to write the rest of it. So I stopped writing it. I was like, oh, I'm not going to do it until they do the work and just actually publish the rest of the type level stack. So when that's done, the service will be fully working, and I won't have JVM. It's going to be a fully native plus JS application. So let's have a look. This is the highlight JS, and while this is something that I'm used to, because I see my snippets on the blog like this, I see snippets even on the Scala website, I think, because it's using highlight.js and all the others. The issue is, like, there's a lot of white stuff in places where it's obvious it has to be highlighted differently. Like function calls, for example, you know they have to be sort of highlighted a bit differently. And there are some inconsistencies, but you can sort of see how the regular expressions works, because everything that is uppercase, or like upper camel case, highlighted as a type, even though in the deref case, it's not actually a type, it's a field. And that's because this is what you get with regular expressions. You cannot, like, you would have to special case so much stuff to have this case work, and then it would be quite slow. So this is a slightly improved version. This is the web version of just rendering spans on an HTML page using the tree sitter stuff that I've just shown you. You can see there's a bit more life, a bit of oomph to it, right? You can see the fields, the deref and index, they are highlighted consistently because they are recognized as actual field access on a particular value. All the function calls are highlighted correctly and separately. The colors, for some reason, actually, I don't know why, I think it's a problem in our highlighting queries in the tree-tiered Scala. There's a lot of overlapping nodes. So we sometimes produce two different highlighting resolutions for a single span. And so you have to resolve that conflict somehow. Otherwise, how do you highlight it? So I think that's the issue with the names of the values. But you can see that it looks a bit better. It looks a bit more consistent, and a lot more things you can just skip over. You can skip over functions, you see field access, and etc. So that's in the web. And let's see my attempt at placing each character manually on a Cairo surface. So it's honestly, first of all, resolution. Look at that resolution. Can you see that it's sharper? Come on, right? It's like Retina versus the 1080p. It's honestly not as bad as I thought. I generated this morning. It's not as bad as I thought it would be. The colors are even more consistent for some reason than they are in the web version. I'm starting to suspect differences between tree-sitter native and tree-sitter JS, which is a horrible suspicion to have. I really don't want to debug this, but I think that that's the issue. But we can still do a bit better. But this is like directly rendering a PNG. Now, I'm running through this much faster than I expected, to be honest. So that's good. On self-reflection, is this good? Like, is this something we want? I think the regex-based highlighting served us well enough, because it does help drive the point across. There are some inconsistencies, and unless you have this crippling disease where you just cannot look at a poorly highlighted snippet, you will be fine. Like, we have been fine, and we will be fine as an industry. Because the tree sitter solution requires loading a 5 megabyte WASM file. So those of us who have a gigabit fiber finally in their houses, you might not care about it. Other people might, if it's your blog that has multiple languages, because the tree sitter solution generalizes extremely well to different languages, because there's so many grammars for every language under the sun, and it's generalizable to everything. It works really well on native. Native is probably it was the most fun to work with, because you just have so much access and you directly access tree sitter, and you can optimize it a lot better. On JVM, you have to still jump through the hoops with native libraries. You have to load them, you have to add them to the loading path. It's a bit annoying. At some point, you have to add a service loader so that it discovers your thing that loads it's a bit crazy, if I'm being honest. I don't know if it's a deficiency of the bindings or if it's a deficiency of my brain, but it was a little bit too difficult for what it actually does. But my thinking on this is that if we liberate the Scala 3 parser, the one that actually knows all of this information, the one that actually can handle ambiguities, the one that can actually use flags to interpret something as a Scala 2 code or Scala 2.13, if we liberate it from the rest of the Scala 3 compiler and cross-publish it, because it's a pure function, right? It doesn't do any type checking, doesn't do any macros. It's a string to an AST, right, Tomek? Yeah, it's just a string converting to an AST, that's it. Almost, yeah. So it's almost that. So I see no reason why it could not be just a cross-published parser artifact. Then on top of that, we could have a DSL that works in much the same way on those produced trees. In that case, the sizes of the JavaScript bundles are going to be much smaller. The JVM usage is going to be trivial, and it's going to be Scala specific and Scala sort of idiomatic. On native, we'll have exactly the same. All the code will be exactly the same. So I think it's well worth doing, and there is precedent for that. Like, a lot of people do syntactic analysis through tree sitter. A lot of people use language parsers to do security analysis. So if we had access to just the parser, we could have what the syntactic Scala fix rules have provide us with currently. So I think that's where we should be going, but this is me showing you how we can use the existing infrastructure of tree sitter and the various grammars available for it to build solutions that generalize really well. You can do the bindings once, and it'll just work across 3 platforms, and you'll just move on with your life and do your algorithms and do whatever. The browser will still be a bit of an issue, like a 4.5 megabyte, I think 5 megabyte WASM file, it's not fun. And also, if you build it on every single commit of tree sitter Scala, it will change all the time. So that's one issue that I have with it. So in conclusion, multi-platform Scala cannot hurt you. So you consider that, you shouldn't be afraid of it. You can do great things with Scala Native and Scala JS. And here is another point. Don't ask if it's production ready. You are the production. You say if it's ready for you or not. You try it, you say it, and it's going to be good. Trust me. Like, you will not be disappointed. Come with an open mind, think of a project you would do, and just use it. Don't ask anyone for permission. This is not prison. You can do whatever. And Scala's type system can help you build abstractions that work across platforms. So you do it once, you commit to it, and then after that, all of your logic just follows from that. So on that note, thank you so much. Thanks for coming.
Okay, we already have questions. Very good.
So my question, Scala Meta is actually the parser liberated from Scala 2, but now also supports Scala 3. Did you try to use it, or would you try to use it for syntax highlighting?
Yes, a long time ago, I actually did build a parser and added very basic semantic tokens support to a VS Code extension, Metal's VS Code, using Scala Meta compiled to Scala JS. It was quite easy. But my issue with Scala Meta versus the core Scala 3 parser is the chasing. So you are well familiar with this, because once the new feature comes out, Scala Meta has to catch up. And the problem is that currently Metals is, for example, running the Scala Meta pass before passing into the compiler. You sometimes have those issues where if the Scala Meta is not adjusted in time, writing some Scala 3 code that parses and compiles might lead to this. Yeah, absolutely. No, like the lead time has been reducing for a while, so the situation is actually quite good. So it's only the experimental features. But I still feel that, first of all, Scala Meta is only available in terms of macros for like Scala 2. So the quote macros. They are. Okay, fair enough. So in that case, maybe it's fine, but still it will never be as concrete as the Scala 3 parser itself, that handles all of the fallbacks, that handles flags, handles all of that. So I feel like it's okay, but we have 2 projects with competing nature in parallel. And I wish Scala, if Scala 3 parser was published as a separate thing, and we tried to use it in a lot of places, we could see how it pans out. But Scala Meta definitely is the sort of the core representation of the syntactic nature of the Scala language at the moment, available for all 3 platforms and for all Scala versions. So it is central to the ecosystem, but I feel like some parts can be handled directly by the Scala 3 parser inside the Scala 3 repository, as long as it's maintained in there. Like no separate parsers anymore, just one parser to rule them all.
I mean, there's a few issues with that. I mean, the Scala Meta parser is a bit more similar to the code, the actual code, while the parser inside the compiler, it kind of loses parts of it. Not much, but it loses parts of the data that you have in Scala Meta. So it's a bit, I feel like it's a bit worse for syntax highlighting. But I had another crazy idea, because there's semantic highlighting within methods that you could actually export, because every, all those tokens, you can actually translate them to any syntax highlighter, and would have actual semantic highlighting, which would differentiate even objects, even if they're small, the non-capital, because I guess a lot of the cases, it depends on the cases where it sees it as a class or an object. For semantic highlighting, it doesn't work like that. So you could potentially use that, especially if you're not doing it, online and you're just generating the picture, you could use that.
But that still presumes the presence of the compiler, because
if you have, running it locally, and you just want to get the snapshot of that, you could have a tool that does it. You could even hook it up to methods to have a snapshot of any code you have. And
absolutely. The reason I looked into TreeSetter is because it's an offline solution, it's language agnostic, and in the end, all I want is, because even in my blog, for example, the number of languages that I currently have mentioned in my blog and use snippets for is about 7, even though it's a purely Scala-centric blog. But I have Swift in there, I have C++, I have C in there, and using a generic system, because TreeSetter was designed to be generic for much more accurate syntax highlighting. It's not pretending to be the most accurate syntax highlighting, and we're not trying to get there. We're just trying to get away from the high or low bar that the regex-based highlighting has set. So that's what we're trying to do, while still maintaining that you don't need a compiler to do that, that you can just basically run it locally, or not run it, like run it in the browser on demand, for example, without the compiler. So I think it's 2 different spaces. One space is compiler-assisted highlighting. You can do a lot of stuff in there, especially if your blog is Scala. You can just use the Scala compiler and semantic tokens and highlight it really, really, really well. I think faster than Lime, the Rust blogger, he actually uses a lot of those techniques along with TreeSetter. So his build is quite fascinating. But there is a different space of on-demand, in-browser syntax highlighting, standalone CLI highlighting without the need of compiler dependency management, or even internet, because this doesn't have internet. So I think it's just 2 different spaces at the moment. But Scala Meta definitely fits in there, as long as all you do is highlight Scala. But once you have multiple languages, you have one for Scala Meta, one highlight of Scala Meta, and one for TreeSetter-based stuff. So I think going with a generic solution can achieve a lot in this space.
Okay, we have time for one more question, I think.
Given that the web bindings are using WASM and everything is essentially returning a promise, how did you manage to unify the interface between that and the JVM?
So they don't return promises.
They don't?
No. So only when you load the parser. I think there might be some asynchronous stuff, because TreeSetter does support incremental parsing, for example, which is supposed to be used for sort of a more high performance, not reparsing the whole tree. Maybe there are some async methods in there. I did not encounter any of them, because from the looks of it, at the moment, once you parse the structure, you get a static snapshot of it, and querying that is purely synchronous. Well, as synchronous as JavaScript would allow you. So the only promise that I saw was the loading of WASM, because the loading itself is asynchronous, and then the creation of the parser was asynchronous as well. That's the only time where I actually saw promises pop up, and that's why I actually had issues, because there was a in JavaScript code, there was a nested await async block, and I don't know how to translate that. It's probably trivial. I'm going to ask Seb to do that, but yeah.
Okay, thanks.
All right, then let's thank the speaker again.
Thank you.